ready now. I'm ready now. Now, can I share my entire screen?
Yes, sir. Please share.
Please let me know whether is it my screen is visible clearly or not.
Yes, sir. Please
Yes.
open
I
your
opened one
PPT.
PPT. I opened
Yes,
one
sir. Yes.
PPT. Right?
Yes, sir.
Okay.
Yes, it
It
is
is
visible.
clear. Okay. Now,
Sir,
what I'm doing is that I am just making it in full screen mode.
yes, sir.
Full screen mode came.
Yes.
Yeah, that's great. So I'm just changing the slides. Please see. Right?
Yes, it is also working, sir.
Right. Good. Perfect.
Yes. Going on,
So,
sir?
yeah.
Let me welcome you, sir. Good afternoon, everyone. It is my pleasure to introduce Dr. BBVL Deepak, sir, Associate Professor in the Department of Industrial Design at NIT Rourkela. Dr. Deepak has an impressive academic background, having completed his MTech in Machine Design and Analysis and his PhD in Robotics and Automation from NIT Rourkela. He has made significant contribution to curriculum development and research in design for manufacturing, industrial automation, and robotics. Dr. Deepak has published over 110 research papers and hold a patent for an intelligent pesticide spraying device. He has also led several sponsored projects and industrial collaborations. His contributions have been recognized with multiple national and international awards, including Institute of Engineers India Young Engineer Award. Today, he will be sharing his insights on chronological developments of technology innovations, role of artificial intelligence, a topic that truly aligns with the spirit of Industry 4.0. Please join me in welcoming Dr. BBL Deepak sir to our session. Welcome, sir.
Right. Thank you. Thank you for introducing me. Actually, I would like to, of course, I am honored to have this opportunity to be as a resource person on this session one. Second thing is that I am thankful to the management of OPJU for giving this opportunity to deliver a talk during this FDP. Of course, this is AI-driven robotics and industrial automation for Industry 4.0 transformation. Of course, this is quite interesting FDP, and of course, like me, there are many researchers are enthusiastic towards doing certain research in the area of AI, robotics, and Industry 4.0. Now, of course, now I am entering into the topic. It is like chronological developments of technology innovation, the role of artificial intelligence. Right. Okay. So please let me know. I'm coming with science and technology now. Is it right? Science and technology slide is visible
Sir.
to you, right? Please.
Yes, sir.
Oh, yes. Thank you. Okay. Now, in the era where we are is the development is very, very drastic. This science and technology, it is in the part of our daily life, and it is changing ever and ever. Like, for suppose, why it is ever changing and advancing, of course, yes. And there are various human factors which influences the new products, and these product design involving in the way of exactly what the human want and what the human is needed, based on these two questions, like the users, they want to use the product, and user what they need. These two questions are giving a lot of new product concepts in our daily life. Now, how it is happening, let us have a look here. Because whenever, of course, I can say here, if you see the design process of a product, it involves various factors. Just like it is a market need, of course, any industry, it is moving towards development of a product with the aid of its need. Okay, then of course the product it is needed to the society or market, but how the science and technology can come up with that product development, of course product design and development, and what are the various business strategies for the developer product. Okay, and the product should be in which kind of environment, not but least the role of designer, industrial design. Like whenever we go to one product, it may be a mobile or it may be like there are so many digital products like refrigerator, AC, or any such products, new products. We are coming up with industrial design concepts, especially based on its aesthetic appearance, right? Okay, once the human is interacted good with that product, then only he is ready to purchase that. If a product is with number of functionalities but the product not seems good, definitely the user will not take. Not only that, user should have good interface with the product. It means that the comfortness he will go through, if the comfortness is satisfied, then only the user will take that product. So apart from this design process, what exactly this science and technology gives us? Here, let us see the technologies are developing for the product development. I mean to say, by the industries, there may be of new or inventions in three aspects. That is, one, new materials, it may be the processes, it may be for the products. Okay, the materials which stands to see what material we do require for developing this product, and if the material is available, what is the specific process that is needed in order to process that material. Okay, so these materials, new materials and new processes for what? For getting new products. Of course the functionalities may be according to its weight. Let us assume that here there are number of mobiles, A type mobile, B type mobile, C type mobile, variety categories are there. And here, of course, we'll be looking at what is its aesthetic appearance. One is that. Second one is that what is its weight, whether it is handy, it is bulky, or it is like compact. Okay, and then what is its cost, right? And what's the new functionalities that the mobile or the product has. So these are the various factors that are influencing towards the development of new products. Thereby the researchers are coming up with new materials and new processes. This is the way how the product design and development cycle is going through. Now, let us see what these innovations, why the technology is coming up drastically for the new products. If you see, there are certain innovations. Okay, these innovations are integrated in the product development or product design cycle, such that the new products are coming into the market. How this is? It may be in four categories. The one is incremental. Okay, in the incremental innovations, what's happening here, you can see, that is say one example is a pen, ball pen. Okay, so this ball pen, the simple functionality is to write on a paper or a book or on a book, right? But these uh, this this pen can be renovated. I mean to say, the innovations can be made with very specific incremental level, such that the new pen can be obtained. Just like now, what I do is that this pen, it will be gone for the survey from the users, and they will come up with some feedback. Okay, and the feedback says that it should have certain features, so and so XYZ, and then the pen now will be integrated to these features X, Y, and Z. Okay, and then I come up with the new pen, right? Not only in the case of pen, but also in the case of any product, such that we can go with incremental in innovations, and then the pen or the product can be in the market, right? And the second one is that niche creation. So this niche creation gives us what is the existing technology. Okay, already the technology is existed. Now we are at the industry 4.0 or industry 5.0. Okay, and how this technology will be adapted to the new market. Okay, here what we are doing, the market is not existed, but we are coming for the new market. Such innovations in the product should be given, especially AI driven products. Then revolution here, what's happening? Okay, the market is established, but we are coming with completely new technology. Here it is what's happening. Okay, let us assume the case where in the earlier days there was the transportation by bull carts or mechanical powered. Nowadays we are not seeing these rickshaws like man powered, human powered rickshaw or bull carts for the transportation. It is means that it is completely vanished. The technology is vanished, and this new technology bringing towards the transportation by vanishing the traditional means and coming up with new solution. Now the transportation is maybe by a bike, car, or locomotion, aeroplanes, whatever it may be. It means that this is a revolution, that revolution coming to the new technology, right? And then architectural is nothing but now we all are observing this kind of innovation. It is like technology with respect to the market and market with respect to the technology. So what exactly user want and what the product should have. Okay, if the product innovation is there, then how the market should be changed, right? Okay, so today the research is going on towards development of various products. Now I apply this artificial intelligence in a mobile, in a washing machine, in a refrigerator, in an AC. Where not, I cannot. Okay, everywhere I am applying. Okay, but here what happening? Now the market is also inclining towards this AI-driven products. The technology to the new market. This is architectural innovations. So these four innovations brings us new products. Let us have a look here. The one example I'm giving. Okay, first I am focusing here on the how the technology is being advanced from traditional to now, and then the role of artificial intelligence will be covered later on. Okay, now here, see, let us have a look here. Okay, at the early days there was a kettle, okay, and which is made up of some metal cast iron. Okay, then afterwards you see that cast iron, left side, the first one. Okay, the cast iron, it's not looks good. Its purpose is to store the hot tea. Okay, so that is the functionality of all these kettles which are presented here. The purpose is one, but the technology is advancing here. 1 to 1 is cast iron, brass, stainless steel, and some sort of polymer, plastic. Okay, and this it is, you can see, if I put these four kettles in front of you and choose anyone, definitely you will go to the rightmost one, because it's not only the aesthetic appearance, but it has certain functionalities to switch on, switch off, okay, and regulate the temperature. The smart features you are incorporating here. Then the same way, if we see the next example, okay, this example you can have a look. Okay, the camera. Okay, and this camera is developed in a such a way that in the earlier days the camera is made up of certain wood frame, right, and it is bulky, right? Okay, those cameras are fixed at some place like photo studios or design studios. Okay, then someone has to go to the camera and they are taking the pictures. After that, certain handy cameras came. Okay, and these handy cameras, however it is there, is made up of some metal. Okay, and the weight of these cameras, the second camera from the left side, it is of course little bulky. Then the camera which is shown here, okay, it is like metallized polymer. Okay, and this camera is very handy and compact as compared to the second camera, right? Okay, then the advancement is going towards its very compactness, okay, and its material uses. Then we get the camera with more features, just like it is compact one. The second one is that it can reduce the material, it can reduce the weight of the product. Okay, so simply it is been used like a kind of paper. Okay, it can be disposed, okay, and it can be disassembled and assembled very quickly. Okay, and you can use it like anything as compared to the previous three versions. So this is how the technology is being developed from earlier days to the nowadays. Now the cycle is going on towards developing the new products. What are the new processes? It is, of course, we are in industry 4.0 or industry 5.0. There was like industry 1.0 onwards, 1.0 to this 5.0, the technology is advancing towards the development of new products, considering the fact of new materials and new processes. Okay, so this is how the cycle is interrelated one to one. Now let us talk about here how the development of this technology is taking place. Okay, now let us see the industry 1.0, where it is in 18th century, the industry 1.0 started, and it is a kind of mechanization. Just the power is generated with the aid of steam. Okay, and using that power, okay, the next operations will be taken place. It means there is involvement of human beings in order to generate the power. Okay, and here there is no automation. Majority of the process where it involves of the human intervention based operations. So of course there is disadvantage with this kind of engine is it uses very limited electricity. Nowadays we all are with electricity. Without electricity we cannot survive. Okay, and the engines with this steam, those are of noisy and those are under poor working condition environments. Okay, so this is how the 18th century people, they are using the industrial based operations. Later on in industry 2.0, some sort of electric means, the power is generated with electric means. Okay, and there it is the development of assembly lines. Okay, of course there is human intervention, but it is limited human intervention. Okay, human is monitoring, human is supervising, and human is giving instructions. And especially for the assembly lines, like one part, another part, like the sequence is preparing and then it is controlling. Okay, so here comparatively industry 1.0, 2.0 gives the good efficient. Okay, and especially it meant for mass production. If it is large amount of goods to be supplied or to be transported or to be operated one work cell to another work cell, then these assembly lines are fine. But when it is coming to the batch production or limited production, then industry 2.0, this assembly lines won't work there. Okay, however you can see this the change from 18th century to 19th century. It advanced from industry 1.0 to industry 2.0. It means almost 100 years time it took to come to industry 2.0 from 1.0. Okay, now let us have a look here. Okay, and then industry 3.0. Okay, so what this industry 3.0 especially means, as we all are from majority of the people are from mechanical based or electrical, electronics, whatever it may be. Okay, so industry 3.0 comes with the integration of computers technology. How this integration is taking place, if you see, right? And industry 3.0 means the integration of computers to the industrial systems, right? Just like the role of robots. Robots can be operated with the support of computer program. The same way CNC systems, right? Okay, these robots or CNC systems or whatever may be the machines, these machines are programmed with the support of computers technology and can be driven towards the execution of certain tasks, industrial tasks, right? Okay, so these from industry 3.0 onwards, actual advancement is under the place. Just like you see how this is going on, like how the computers uh, are integrated in the industry. If you see, initially it has certain drawing or the design, okay, that is also in computer environment, that is called computer aided design. This design gives us the 2D views and 3D views, right? Okay, then these 2D or 3D views, then what we will do is that we will send this virtual model to the machine through certain operations by generating like G code and M code with the support of a computer aided manufacturing tool. Thereby the CNC will be automatically operated and it gives us the the geometry of the part what exactly the user need, right? This is one way. And second thing is that this L2 manufacturing also coming into the picture here. This CAD file can be generated into slicer. It's like layers, okay, and then this layer by layer it will be added, okay, and then the final product will be coming, okay, that is with the support of a 3D printer. Okay, now these 3D printers are CNC machines are here. They use the computers technology to go for this new product. This is how the computers are integrated in the case of 3.0. Of course, industry 3.0 or 3.4 not only concentrate on the computers integration, but also it is the integration of various disciplines. How it is, let us have a look here. First of all, as you know, for any integration some parts or the products are required, okay, and these parts are to be imparts its motion or the mechanism, okay, and once the mechanism is created, the analysis will be taken place maybe in terms of its kinematics and dynamics, etc., etc. Just like I am giving the example here, a robot or a CNC system, whatever you can consider. Okay, now a robot you are considering here, it means that the robot, what is its mechanical structure, how many links, how many joints, what is the degrees of freedom, what is its workspace, what is its reach, okay, you need to define this. Once you define this, then this mechanical architecture to be operated with some source of power. That power may be some means of electric or hydraulic or pneumatic. So who gives that power? Of course we all know the motion analysis can be performed by the mechanical engineer, but when it is coming to the the power system, then it is the role of an electrical engineer. He gives what is the amount of power do you require, then what is the type of motor you have to use, what is the type of actuator it should be, such that your robot will be under actuation, right? Okay, now it is there, the mechanical structure is there, and you simply fix it some motors, right? It is not the sufficient task to do, but here you have to integrate certain sensors to sense the environment, and accordingly it has to operate in the environment to complete the industrial task, right? So this sensor technology will be provided by an electrical engineer. See, now the role is mechanical engineer, of course electrical engineer and electronics engineer come into the picture, and then the software technology, like here the computers, it is has the role the software or the programs or the instructions they will give in terms of commands to operate the system in intelligent manner. That also we can say as expert system, right? No, on integrating these disciplines, what you will get, you are getting one interdisciplinary new product. Okay, so this interdisciplinary new product which we are using at this moment, like of course the industry 3.0, the products are interdisciplinary. From industry 3.0 to industry 4.0 and industry 5.0 or industry, of course in future we may get industry 6.0 also, there we are using. Okay, so this is an example for a robotic system, right? Right. Okay. Then, this industry 3.0, if we see here, 18th century to 19th century, industry 1.0 to 2.0 came. Then 2.0 to 3.0, this robotics technology came into the picture in the year of 2000. So here, see, 18th century to 19th century, almost 100 years. Again, 19th century to 20th century, again 100 years. It is taking time to revolutionize the technology for around 100 years. Of course, what then extra we do require? Of course, we are achieving the works by this industry 3.0, but what it needs? It needs skilled works or skilled labor. It means that the user or the worker who is operating in these devices like robots or CNC systems, they have to have knowledge on operating the machines. For suppose if one CNC system is there, the worker should be very proficient in using CNC, others he cannot use that, right? Okay, the same way the robot also, it cannot work without the good programmer or the one who knows the knowledge on this actuator sensors and all. Okay, so this is the main problem here with the industry 3.0. It is like the necessary of skilled workers. Of course, as compared to the previous industry 1.0 and industry 2.0, it is quite good and gives us the efficient, efficient works and products. Now, let us see here. Industry 4.0 came into the picture. So this industry 4.0 gives us what? Okay, what we lack there in industry 3.0 and what it gives. Okay, here in this industry 4.0 or industry 4.0, you can say any version. Okay, here we are automating everything. It means that the role of computers is integrated such that the manufacturing industry can accommodate the works from beginning to the ending. Like here one smart industry is there. Okay, and in that industry, okay, the inputs raw material it is supplying. Okay, then the robots are doing certain tasks, or the automated devices it's doing certain tasks. Okay, then the material will be transported. Okay, and then it will be gone to the deliveries, packaging, and then it gone to the delivery. Again, there are also certain unmanned unmanned systems, unmanned grounded systems or unmanned aerial systems, whatever you can say, those are there. Okay, and with the aid of these unmanned systems we can do transfer these goods, right? Okay, so here what's happening, previously the user should be a skilled one, but here there is no involvement of human being. Like the work whatever it is doing, okay, with the support of computers technology, and you are controlling all the machines one after one, where to come and when to come, and you are observing the complete system. You are monitoring the complete system, and the robots are taking the action accordingly. means that here you are using these cyber physical systems such that you will integrate one system to another system through internet of things, just like robot 1 and robot 2, robot 3 and robot 4 should be here, okay, and robot 5, 6, 7, 8 should be somewhere, and one autonomous guided vehicle should be somewhere here, okay. Then the material should be transferred one to one as like this, right, okay. Then these robots are coordinated one to each other, and it knows what's the sequence of operation, okay, that is called job scheduling, we can say. Once the sequence of operations is known, then the robot 1 is performing certain tasks, robot 2 is performing certain tasks, and then again the material will be transferred to the robot, some robot number, then it will be at the delivery by the again some autonomous guided vehicle, okay, or UGV or UAV, of course, in anything what we can say, okay. Then these are operated through internet of things as well as artificial of intelligence, okay. This artificial intelligence gives the robot to execute the task intelligent way, right, okay. This how the product or the process of industry is taking place. Now, what the advantage is with this industry 4.0 as compared to the previous, if you say, one, we can go for the smart factories. This smart factories means the complete, the complete process can be automated from initial to the beginning. So, initial beginning step to the end step, that is called delivery. Second one is that timely work tracking. Timely work tracking means, for suppose example, the first one is there, first work is there, the second work is there, the sequence of works are doing here, whether the sequence is exactly executing or not, monitoring can also be done easily, right, okay. Then greater customization of production systems, of course, where the work is some disturbance are there or stopped or some emergency occurs, some uncertainty found, then what happens here, the user or the master, the engineer who are there, okay, he can monitor, and if some certain uncertainty presents, then he can simply replace the robot with another robot, or he can troubleshoot the robot very quickly, whatever may be the solution, okay. Then he do the operation, okay. So the customization, that is one way. Second customization is nothing but what, now the product is changing, product A to product B, a certain operation is to be changed, okay. That operations can be changed very quickly here. So instead of using two robots, you can keep three robots. Instead of keeping three robots, you can integrate two robots works in one robot and another robot. Okay. So this is nothing but what, greater customization of production system. Okay. Now, of course, in industry 3.0, there is a need of skilled labor. Here, what we are doing without human intervention, we are operating the complete system. So this is how we are doing work. Okay. Then what is this? Apart from the advantages, there may be disadvantages. What is the disadvantage? If we see, the disadvantage is the major cyber security issues. Okay, what this cyber security issues? If the system or some data is hacked, okay, then it will be the complete data can be theft by the hackers or something, okay, and that can be used by in some other way, and it is little dangerous, right? If the security systems, just like in defense side or some other means where the security is high essential, then it should have good security, okay. So this is how, of course, completely human intervention we should not avoid. So there may be certain case of human collaboration, of course, that we will discuss now. Now, what is happening? You see, the industry 4.0, what is happening here? Industry 1.0 to 2.0, it took 100 years. Again, 2.0 to 3.0, it took 200 years. And here you can observe industry 3.0 to 4.0, it just took only 10 years. It means that in 10 years of time, there is a huge development in the use of IoT, Internet of Things, okay, and artificial intelligence and machine learning. This is the power of AI and ML that is being implemented in industry towards the execution of tasks without human intervention. Now let us have a look here. What else we do require? As I emphasized there, Industry 4.0, it has certain drawback. The drawback is there is a problem of cyber security. So here the cyber security problem happened is nothing but whether it is robbed or it is like some some threat is there for our data. Who can monitor? The human can monitor, right? So if the system is in collaboration with the human, okay, then this can be avoided. Okay, so that what here in Industry 5.0, it is concentrate on human robot collaboration. A robot is there and the human is also being there, okay, and this human being and the robot both are doing the work, and these two are collaborating one to one. This is like collaboration work. It means it is a human centered or user centric design system, okay, and the robot acts as like human being. If some if some cyber security issues came into the picture, then it can understand with the human intelligence and it will be avoided in this case of Industry 5.0. Right now, I'll give you one more example here in case of Industry 5.0. There is an assembly to be generated for 10 parts, okay, and part 10 is very bulky. Part 10 is bulky, okay. So this bulky part is there, which is, let us assume that the weight of the part is 20 kgs, and I have robots which can do work very fast and very intelligent manner without any human intervention, okay. But the payload of my robots that I am working with are 5 kgs or 6 kgs, right? Okay. So now what's happening here? This 5 kg robots anyhow I cannot use here. So what I have to do is that I can recruit one human being there. Okay, he can handle this 10 kg of part with himself. Okay, and whatever the remaining parts are to be assembled, the robots can do it. Right. So this human, he is holding this 10 kg part and he can rotate in any direction, and the direction or orientation can be recognized by the robotic system, and it will do operate towards this execution of the assembly in order to complete the product. Right. This is how the human robot collaboration should be there to execute the tasks in high level of customization as per the human requirement or as per the industry requirement. Now, let us see here. Now I am going into the picture of a robot. Okay, so a robot is nothing but what it is to be operated, means it has to know what is its environment, right? Okay, so certain environment is there, whatever it may be. The environment may be for doing welding operation, maybe for pick and place, maybe for assembly, whatever it may be. So certain environment is there, okay, and then the environment is to be captured via some sensors. Once the sensors got the data, then it has to percept what is the useful data and what is the noisy data, such that the noisy data can be eliminated and the robot can use it, the only useful data. Okay, once it gets the the environment with certain data, then it will localize where am I. Okay, it has to question by itself, like where am I, so that it can maneuver in its environment. Okay, once it knows its position, then it will plan where I have to move, or what is the action to be done. Okay, this cognition or planning, in this case, it is the role of artificial intelligence. The cognition or the motion planning can be provided to a robot with the support of artificial intelligence. Okay, so here we are giving that artificial intelligence based motion planning technology. Okay, then this motion planning, once that is done, then we will simply interface this to the controller, and then the controller to the actuator commands will be go on, thereby it imparts the motion, right? And one feedback system will be there, whether exact location the actuator or the mechanical link is imparted or not. Now see here what is happening. For any kind of robot, we have to identify what is its locomotion. Locomotion means its maneuverability, its motion ability. Okay, so in this case what we have to do, just see there are various categories in this motion inspired. One is that, like, as we are the human, and if you see the human inspired, this is a kind of a robot which inspires the human behavior. It is called a biped robot. Okay, the same way an animal inspired, okay, of course this is concept too. If I see it mimics the structure of an animal. Okay, and another more moving ability is a snake type, like a sliding robot. Okay, so what we are doing is that initially we have to analyze what type of locomotion or the motion ability that we do require. We have to analyze. Based on that, we have to go for the development of the robotic system. Then it may be one vehicle inspired, right? Okay, wheel kind of robot, and it may be the inspiration from the jump. Okay, a robot can sense and it can jump to the certain height. Okay, so this is like it can move over to the wheel and it can jump. This is like a wheel assisted jump inspired robotics, and the jump can be with the support of legs, just like a kangaroo, how it mimics the motion of a kangaroo. Okay, then apart from that, the robot can fly over the, just like a bird inspired. And of course another category is like a fish inspired, which can do the work as underwater system. Okay, now what we have to do, now we have various concepts. Okay, now my application is this one. Okay, so since your application is this one, what kind of locomotion you have to select? First you have to identify that. Okay, once you identify that, then only you will go for the kinematic and dynamic analysis. Of course, whatever the cycle I emphasized previous, mechanical, electrical, electronics, and computers, thus you can implement over here. Okay, once. Okay, so this is like there is no fixed volume. It can move around anywhere in the environment. Now you see here the concept how it is for a fixed or limited workspace. For suppose, just like our human beings, we can move with our legs. For suppose we want to do certain work in its fixed position, means, okay, we are standing and we are doing the operation. The same way a robot can be fixed somewhere and it can do operate, just like a robot manipulator. So what categories of these robots are? The one is Cartesian, okay, which can move in X, Y, and Z directions. Okay, and it is a cylindrical workspace robot. Okay, and it may be a spherical workspace robot, or it may be a kind of articulated robot which inspires the human arm structure, right? Okay, so this is what the locomotion of a robotic system. Okay, now if we see this application based robots, okay, and these systems can be like whatever I emphasize, these concepts can be incorporated in huge sectors for various applications. Of course, here the applications are not mentioned because we are now moving towards the application of artificial intelligence, how a robot can be controlled. Just like all of us know there are like just let me give the definition of an artificial intelligence initially, then I'll go to this motion planning strategy. Okay, now you see the human is there or the bird is there, whatever it may be, living creature is there, it has certain intelligence. Okay, I have my own intelligence as well as you have your own intelligence, as well as if you consider any living creature, they have their own intelligence. This intelligence is natural and this is called natural intelligence. Apart from that, this natural intelligence, if we incorporate to a machine, okay, to do certain tasks as like human being, it means that the machine is applied with artificially some sort of intelligence is called machine intelligence or artificial intelligence. This is a simple definition of artificial intelligence. Now, like, of course, the artificial intelligence, it is the inspiration. Okay, and how the inspiration coming into the picture here, we can say the one is particle swarm optimization. What exactly this particle optimization will do? Here the particle optimization works in the behavior of swarm intelligence. Always a group decision is best than individual decision. Of course, all of you will agree with that, right? Okay, now what this group will do, they discuss among themselves. Okay, and then they, after this communication, they come up with one solution. So this is the best one. The same application can be here, we can implement to a robot for its motion. Okay, how it is, let us see here. Now let me play. Please let me know. All of you are is it visible, my video? Hello?
Yes, sir. Visible, sir.
Yeah, thank you. Okay. So this particle swarm optimization, how it is inspired. Okay. Among a swarm, I am considering one particular, one bird. Okay. And the bird has its initial position, let us say it has the initial position of X. Okay. And it has, of course, it is moving in some direction. So it has certain initial velocity. Now, what is happening here? Now, this bird want to move to its best position, that is called position best of the particle or the position best of the bird. Okay, then what's happening? There are n number of birds as like this. Okay, and these n number of birds, they communicate each other and they decide that this is the best position among the swarm, right? Then the individual will try to approximate to the global best position, right? Okay, this is how the particle swarm optimization works towards finding the global best position, towards reaching the global best position. The same concept we are applying here, how it is. Okay, now the robot is in motion in the presence of obstacles. Okay, and it is moving towards the goal, right? Okay, and then it senses certain obstacle in front of it, then it creates a swarm. Okay, and this swarm creation is happening how, like, uh, the swarm is created, then the robot will see these parameters. What are the parameters? The distance between the robot and the target, the distance between the robot and the nearest obstacle. Okay, and the total distance traveled by the robot, or the time taken of the complete path of the robot. Based on these three aspects, we are generating a fitness function, and which satisfies which best position of the swarm satisfies this criteria will be treated as the global best position, and the robot, then the robot will move towards that global best position. Now again, we can go to that video how it works. Okay, so here you can see the swarm generation, as well as the robot is targeting towards one position, okay, which is marked in red color. Okay, that is global best position. See, swarm is generated. once the obstacle is presented, means it is generating swarm. Okay, if there is no obstacle, then it follows the green path. Okay, once the again obstacle came, okay, and it is generated swarm, and it is doing certain analysis for its fitness evaluation, and then it is moving towards that best positioned value, then it is moving towards the target position, right? So this is how it works, okay, without swarm, the path, right? So do you think this is the optimal? Of course, obviously this is not the optimal, but this is one of the solution that the robot may do. Artificial intelligence may not give the optimal value, but it may give the approximate to the accurate value, approximate to the optimal value. So this is the power of artificial intelligence. So now previous I don't have any knowledge where to move and how to move, but with this motion planning strategy somehow I got, okay, with further refinement I may go for some more optimized path. Okay, so this is how the particle swarm optimization works. Okay, so without the swarm, how the robot, what's the motion of the robot, right? Okay, then it is moving towards the target and it reaches to its target, then it will be stopped there, right? Okay, now so this is how the that it works. And here you can also observe that there may be the chance of number of parts that the robot may face, okay, and among this what is the best we have to find, and then we have to do certain evaluation further for the refinement of the path. The second is immune-based system. Immune-based system means apart the previous one is a swarm inspired. This one is immune inspired. So immune inspired means what it is? You can say here the human immune, how it works. We have the body, okay, which has some immune system and which protects us from certain invaders. Just it is called antigens, bacteria and virus, okay, and from there it protects us. Okay. How it protects us? For suppose if in the environment, if certain invader came, the invader is the cause of cold, then immune system what it does, it generates certain b cell antibodies. From the b cell antibodies, other protective cells will be generated, and these protective cells are trying to neutralize the invader, the virus or the bacteria, whatever it may be. Okay, once it succeeded in its operation, then it will neutralize the external invader, and once the it is neutralized, it means that the immune system is good. For suppose if it is not neutralized, then what we have to do, we have to take certain supplement to increase the immune system such that the cold related antigens or the virus will be suppressed, right? Okay, the same behavior we can incorporate to a robotic system. How? So in the case of immune system, we are considering one intelligent mobile platform, okay, and this intelligent mobile platform which has a number of actions: move left, move right, move back, 0 degree, 10 degree, whatever it may be, the robotic actions, right? Okay, and the environment is there, environment, no obstacles, left side obstacle, right side obstacle, whatever it may be, there may be number of environmental criteria, okay, and this will be in behavior learning in between the environment and the robotic action, then it will decide what to be done and how to be done, right? Okay, then it goes to its path just like this. Okay, here it is, you can see how our system work. That I'm going there. So here this is the antigen, kind of bacteria or virus, and which is equivalent to the environment in the robotic environment. Okay, B cell, which is an intelligent robot. Number of antibodies by the B cell is nothing but the number of possible actions by the robotic system. Okay, then certain immune responses will be given according to here behavior learning we are making, and then among the solution what is the best suitable action, it will be decided. So this is how the robot is moving towards the target. I mean, say anyhow, the robot has to move towards the target. So it means the heading angle is one antibody, move, go towards the target. Then another antibody is that if some object is there presented, okay, move straight. Okay, if object is in trap, like u type or t type or whatever it may be, in trap situation, move the robot in reverse direction. If the robot in right side or the left side, the robot has to move in right side or the left side. Okay, so here various colors that are representing various robotic actions, and the robot now is moving towards its destination in certain iterations of time. Okay, and finally once it reaches to its destination, once the robot is reached, then the task is completed, then the program will be ended here, right? So this is how the artificial immune system works. Okay, so immune system is the natural and artificial immune system is a kind of artificial immune system. So this is how the robot works. Not only that, there may be various like small student project based robots you can observe here. One is a DTMF inspired robot, okay, uh, which can control to which can operate with the support of signals, DTMF signals, is with a small phone, okay, and then this is a kind of edge detector. These sensors can be incorporated to detect the edge and take the action accordingly. Okay, right? Right. And then with the aid of gesture control, so we can do. Of course, these are small project pilot based models. With high implementation, we can use this technology in scale models, right? Okay, then of course this is like a keypad control, just like DTMF initially with the, okay, right, right, okay. Then this of course, and the light avoidance robot. Okay, if the light is there and it maintains certain distance, right? Okay, okay, then kind of obstacle avoider. If some obstacle presents, then tries to avoid the obstacle. Okay, if a line is given, then on the line it follows, and to move over the environment. Okay, so this is a line follower or path follower. Okay, then we can have, of course, previous one is light avoider, it is light follower. Where the light is there, it follows the light, right? Okay, so this is how the few of the robotics that are developed. Of course, we have some more robots also. I am unable to see here. Okay, so this is how my topic for 1 hour. Right. Thank you once again to one and all for giving this opportunity and be patient towards listening my talk. So, in case, of course, Professor Soros, and if you have any questions or discussion from your side, I am happy to clarify.
So much, sir, for your insightful and enriching session. Now we would like to open the floor for queries. If anyone has any query, they can raise their hand. I will allow them to ask this question. Anyone
All
from
the
audience?
participants, just raise your hand. The host will allow to speak you. Hemant sir, I think no queries from attendees, so we can proceed towards closure of this webinar.
Right.
Thank you, sir, for this wonderful session. Uh, I think there is no queries from our participants, so
Okay.
we can stop the session here. Thank you, everyone. Thank you, sir.
Right.
Thank you, Deepak sir.
Thank you,
We will.
Soros. Thank you, Hemant, for
Thank
giving
you,
this
sir.
opportunity. Okay. Again, we'll meet you. Right. Bye
Sir,
bye.
sir, in our Atal FDP, which is
Soros,
going to
आवाज नहीं आ रहा.
uh,
Your voice is not coming.
now.
Yeah,
Is
now
it?
it's fine. Now it's fine.
Yes, actually, sir, your name is in our Atal FDP also. If it's sanctioned, then you have to come in physical mode.
Uh,
My voice is not coming, sir.
oh, okay. Oh, okay, 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 okay. Mm-hmm. No issue. Let me know, Soros. We'll discuss.
Yes, sir, sure, sir. Thank you, sir.
Okay. Bye. Bye, Hemant sir. Uh.
Bye, sir.
Yes. Yes, Hemant sir, we can close this webinar.
Recording, I can stop.
Yes.